Okay, welcome to Unleashing Chaos and Breaking Containers. I'm the MC for the talk. My name's David Butler, and it's great to see everybody here. I'm with Docker in product marketing. But it's great to have Anna Medina here from Gremlin. She's an expert chaos engineer from Gremlin, and as well as her past company, Uber. She did a lot of work with site reliability engineering as an SRE expert in and around infrastructure. So it's great to welcome her to the stage. Welcome.
Thank you. Hey y'all, thank you very much for coming to my talk. Today we're going to be talking about unleashing chaos engineering and breaking some containers. So to start off, my name is Anna Medina. I currently work at a company by the name of Gremlin. We currently focus on building a chaos engineering platform with a mission to build a more reliable internet. Prior to working at Gremlin, I've gotten a chance to work at all different scales of companies, including Uber, Google, Quicken Loans, a small credit union in South Florida, a startup in South Florida, and I got a chance to also do some cool college research. I was born and raised in Costa Rica. My parents are from Nicaragua, but I currently reside in San Francisco, California. I started coding about 13 years ago, mostly on the self-taught web development, then backend, and then mobile, and then 3 years I found my way into the infrastructure space, starting with site reliability engineering. I'm a proud college dropout, and I kind of like giving that a shout out so folks know that my imposter syndrome is real, and it's okay to come from all walks of life. If during this talk or after you have any questions about chaos engineering, Gremlin, or about my life, you can shoot me an email over at anna@gremlin.com, as well as find me on Twitter. I post a lot of cool stuff, mostly in the diversity and inclusion space, technology, and mental health. So what are we going to be talking about today? Well, hopefully I get your face from that minion of being, hey, I'm not sure what this is, to, whoa, this is really cool. So we're going to be talking about what chaos engineering is, how you can actually get started and do it carefully and thoughtfully, as well as doing a live demo. We're going to be breaking some stuff. This will be a live coding demo, so we're going to hope that everything goes well, and if not, we'll figure it out. So with the raise of hands, how many of y'all are familiar with chaos engineering? Cool. So just to set the ground, chaos engineering has a few different definitions. For some folks, it just means breaking things on purpose. For some other folks, it means just testing on production. Well, the CEO of the company I currently work at has a definition of chaos engineering as thoughtful, planned experiments designed to reveal the weaknesses in our systems. And there's a key part in talking about that thoughtfulness and that planned. It's not about just randomly inserting chaos and not letting anyone know and just doing things for breaking things purpose. And for some folks, using the analogy of chaos engineering being like a vaccine makes a lot of sense. You inject something harmful in order to build immunity. So you go ahead and you put a little bit of chaos engineering into your systems, your containers, hoping that you're going to be able to find the weaknesses and then build more resilient systems at the end of the day. So I mentioned chaos engineering experiment, and you kind of wonder, what does that actually mean? Well, the way that you think about forming a chaos engineering experiment is kind of like the scientific method that we learned early on, where you kind of ask, what can go wrong? What actually happens if this part of my systems fail or my software? Then you go ahead and you thoughtfully create a hypothesis. If X fails, Y is going to happen. And that way you start thinking about what you need to be measuring now, what you need to be measuring as you're performing the chaos engineering experiment. You have to measure the impact. You want to know how your system's doing right now, how your system's doing while the chaos engineering experiment is performed, as well as how the system is behaving after the chaos engineering experiment. Since we're doing this in a very thoughtful and very planned way, you want to have a rollback plan. a lot with chaos engineering is education and safety. So having a big red button that stops all chaos engineering experiments is highly, highly key. Whether you built a platform, you use an open source tool, that's one of the number one things that you need to have in place. And then, when you do chaos engineer experiments, you have to do it carefully. So for some folks, that means starting chaos engineering in staging, development, before going over to production. For some folks, that means thinking about, hey, why should I run this chaos engineer experiment on 100% of my fleet when I actually don't know how this chaos engineering experiment behaves on just 5% of my fleet? So you have to be thinking about this, something that we call blast radius. And at the same time, if you perform a chaos engineer experiment and you start seeing in your monitoring that something's broken, you want to go ahead and stop that experiment, go ahead and fix what's possibly broken, and then repeat this chaos engineer experiment. So if you feel like this and you're super stoked to go break things like I was, well, hold on. There's some prerequisites you need to have before doing chaos engineering. The number one is you must have monitoring and/or observability in place in your systems. That way you actually know how your systems are behaving before you insert any chaos. If you just do chaos engineering, you're just gonna have your systems on chaos, and that's not necessarily as fun as when you do it in a very thoughtful way. There's other prerequisites of having an on-call and incident management, just in order to form that good practice of, hey, we're pretty much doing like little fire drills when we do chaos engineering. This lets us look back at our runbooks that we have in place, as well as make sure that our monitoring on our alerting is in place. So when you have that on-call and incident management program set up in your companies, your organizations, you kind of like are able to do a little bit of muscle memory and do kind of like fire drills with your team. So if you have that in place, that's great. Another thing that you want to have in place with chaos engineering is communication. You want to make sure that you're telling folks that you're going to be doing this chaos engineer experiments on the systems. This is not about just doing, hey, I'm going to do a chaos engineer experiment to see if my folks on call are actually paying attention to the pagers. That's not cool. Chaos engineering is not about that. It's more about coming together as a company and making sure that you're building resilient systems together to have less downtime, to have less outages, to have less pager pain, and to have happier engineers. I know that when I got put on call, it was basically just throw the pager and figure it out, here's a runbook. So when that page comes in my third week at the company, and I look at a runbook that's 180 days old, I have no idea what to do. So it's kind of like that same thing with chaos engineering. You want to make sure to do it in a more careful manner and be empathetic to the engineers that are currently watching your systems. And then I mentioned earlier the blast radius. You want to think about how you're going to perform these chaos engineering experiments, how you're going to gradually roll them out. So you first think about that initial test. What is my chaos engineer experiment going to affect right now, and where do I want it to go after a few iterations of these chaos engineer experiments? And that's what we call the blast radius. So for today's environment, I've kind of gone ahead and done the pre-setup. I have 3 droplets from DigitalOcean running Docker CE. With Docker Swarm, one is a leader, I have 2 nodes. I've set up Datadog for monitoring, and I've installed Gremlin free as a chaos engineering platform. Feel free to go over to the IP address of 138.1.97.212.101, port 5000, and you'll be able to see a voting app that is a GitHub repo of Docker samples that allows you just to vote, what do you prefer, cats or dogs? So that's kind of like the application we're going to be using today. This is the application. You can go ahead here and vote dogs. And we can actually pull up the results over at port 5001, which lets us see how y'all are feeling. Maybe dogs, maybe cats. Seems like dogs seems to be the prominent solution for y'all. So I just wanted to show y'all the containers that we have running. We have, can you all kind of read that in a way? Sweet. So we have the Datadog running, we have the Docker samples for the example voting app, And we also have set up another Docker sample known as a visualizer that allows you just to kind of like see what containers are running on every single host as you're running Docker Swarm, which is a pretty cool, not necessarily monitoring, but it gives you a little bit of the visual as you're performing these chaos engineering experiments. And then over to show that I have already set up Docker Swarm, we can show the nodes where we have host of Docker Conno 1 being the leader, as well as the 2 other hosts that I have pulled up here that are just the other nodes for it. So I wanted to show you all the visualizer I had mentioned earlier, and this just kind of like shows how it's currently distributed, like the voter app, the Redis containers for that, the database for that, as well as the other visualizer. So we're going to get started on the first chaos engineer experiment. But prior to that, I'll just mention this is a somewhat introduction to chaos engineering. There's a lot to cover with chaos engineering that I can't cover in the 40 minutes I have today. Today I'm going to be talking about just the chaos engineer experiments of shutting down hosts, shutting down containers, as well as increasing CPU on hosts and containers. But there's a lot more to chaos engineering. You can do attacks on the state layer, the infrastructure layer, the application layer, as well as the network layer. Basically, a lot of the things that you can think that can currently fail or that have cost you pains when you're on call, you can build a chaos engineering experiment around that. So for today's, we're gonna start with talking a little bit of like site reliability engineering. Site reliability engineering kind of has been around for what is known to be 11 years. There's a huge book on it known as the Site Reliability Engineering Bible that's come out of Google. Well, in that book, they decided to put kind of like the hierarchy of what's the most important when you're developing systems. Monitoring being one of the base layers that you need to have so you know that it's resilient, and then you can continue building on top. Then comes incident response, postmortems, testing and release, capacity planning, development, followed at the end by product and features. So today, we're starting all the way at the bottom. We want to make sure that our monitoring is set up in place, that we actually know that things are going to go well. So for the first experiment, we're actually going to go ahead and go over to Gremlin and do the first chaos engineering experiment that's going to be targeting the container that is currently running our visualizer. So we're going to actually see how this behaves as this happens. And of course, a hypothesis for this, does anyone have any ideas what's going to happen when I actually just do a shutdown of this container? Anyone? Well, the container will just get shut down, and then also Docker Swarm is just going to make sure that it actually gets set up and get respawn up. So we will actually see a little bit of downtime, but it's actually not that much. So today I'm going to be using Gremlin free. It's completely available to do 2 free chaos engineer experiments, which is shutdown and CPU. So we're going to go over and find a container that's currently running our visualizer. Then we're going to go over and we're going to shut down the container. We want it to be now, and we don't want to shut down. We don't want to tell the container, please come back up. We want to make sure that this is just done for us. We kind of move to containers to whether it's Docker Swarm, whether it's Kubernetes, because of the promise of more resilient systems, more reliable systems, but we actually don't know until we test this. So we just want to see if our monitoring actually catches that our container goes down and what actually happens to our application. So we're going to go ahead and run this chaos engineer experiment. So we still see that the containers have been created 3 hours ago. Everything is still working. Our visualizer is still working perfectly. Okay, so seems to be an issue of not being able to find it. It's been up for 3 hours. No, that's a Datadog one. We actually see that the visualizer is not there, is it? Yeah, this is a vote visualizer, so that one's still not back up. And now we see that 13 seconds ago, the health is starting for the Docker samples visualizer container that we just shut down. So it's going to take a bit for it to come back up. And then we wanted to see if we actually set up our monitoring and alerting properly. So we go over to Datadog on the container side of, on the container monitoring side of things. And we will actually see that about a minute ago, the visualizer container has come back up. So that's great to see that it's back up, but our application is still not live. I spoke too soon, it's back. So that was good to know. We now were able to test, hey, if something happens to my container, Docker Swarm is gonna bring it back up, and I did not have to do anything else. It automatically said, I'm gonna announce myself on port 9020, which sometimes that's not out of the case. You shut down a container, and the container will come back up, but will not advertise the port that it's coming on. So it's also good practice to make sure that if your containers are constantly coming offline or just shutting down and another one is spinning up, everything still works properly. Just gonna check if I got any Datadog monitoring alerts. Yes. So as well as showing the Datadog monitoring side that we can actually see, I had also set up alerts that, hey, DockerCon, it seems like your container is down. And in a few seconds, we'll get another Datadog alert that just is going to show us that our container has recovered and everything is back to a healthy state. So for the next chaos engineering experiment, we're going to be doing CPU. We're going to be targeting all the hosts. So that's going to be DockerCon 01, DockerCon 02, and DockerCon 03. And it's basically just a question of what actually happens if the CPU load on all my hosts is maxed out. So we'll go over, and this time we're going to target the hosts instead of the containers. So I've gone ahead and selected the 3 hosts that we have chaos engineering installed in. Then we're going to go over and select the CPU chaos engineer experiments. We want to run this for a little bit longer just so that our monitoring on alerting picks it up, as well as we're actually able to see if there's any issues in the application as we do this. And the CPUs that I'm using, the hosts that I'm using today are running with 4 cores. So because I know this, I'm going to select that I want it to be using the 4 cores. Another of the things that I didn't mention that you can do with Gremlin is that you can actually set up to run this chaos engineering experiment at a later time. So if I actually want to, I'm able to say, I want to run this tomorrow, or I want to run this randomly, which is also another really cool feature. But for now, we're going to run this now. And to show how things are going, I'm going to pull up top on the 3 hosts just to kind of show a little bit of the load and the CPU utilization that's going on. So we start seeing that the CPU is starting to go up, and that is because the Gremlin daemon is currently spinning up a little bit of CPU usage. Then if we go over to the host view of our Datadog, we will start seeing that, let me give it a second. The DockerCon containers are starting to go up on utilization, and I have a tag set up that I'm able to do the service DockerCon. We start seeing the DockerCon 02 is starting to get more CPU utilization than the other ones. And since I put it to run for the 180 seconds, 3 minutes, it's going to take a little bit of time to get to a higher number of CPU usage. But the cool thing is that this is also another way that you can test your alerting and monitoring, as well as your load balancer. You want to know how your load is being handled across different containers as your CPU is spiking up. And then we also want to know how this application is currently getting affected with the CPU load. And it actually seems that the application is working well, which is great. That if you were to have like a memory leak in your application, even if it's running in a container or on the host, things still continue running smooth for the user, which is great. And well then, seems like dogs are really winning this one. Anyone want to vote for cats so they're not left too behind? The cool thing about this too is that you're actually able to see what container the view is actually going to be using. So this is going to be handy for the next experiment that we run. And as I mentioned earlier, one of the first safety features you want to know that you have in your chaos engineering platform is that you have either a button to halt that process, that chaos engineering experiment that you have going on, or you have another red shiny button that halts everything that's currently running there, just for safety matters. So in the case that, let's say that we would actually see that this application is completely unavailable, or it's taking way too long to set up, or there's something wrong with the results or anything, you can automatically set that to stop. And another cool thing with when you're thinking about your chaos engineering platform is that you can actually have your monitoring trigger an API call to your chaos engineering platform to stop those experiments. So let's say that you have it set up, if you see your traffic is dropping, like even if it's like 5% when a chaos engineering experiment is going on, you have that set up on your monitoring, and then that triggers the API call to halt the chaos engineering experiments if you actually think that that can actually affect it. And that's actually really good when you get to the point of maturity that you get to run your chaos engineering experiments on production. Doing chaos engineering experiments in production is not about breaking production, it's just more about validating that you're building resilient systems in the production environments too. So I believe the CPU attack has gone ahead and finished, and we'll be able to see that it has executed on the 3 hosts, and everything has gone well. And it has also rolled back that now we actually see that our hosts are running back at healthy states, or like back to normal CPU usage. So for the last chaos engineer experiment, I wanted to show a little bit more of disaster recovery. What actually happens if you need to move from an entire data center to another, or completely just move over from other hosts to another platform. So we're actually going to go ahead and shut down a few more things this time. We want to go over to containers, and this time we actually want to shut down all the containers on the namespace of Vote. So everything that's running on our Vote application will be shut down. So we're going to actually go ahead and select it all. And we can verify if we actually wanted to on our visualizer. Give me a second. These are good, like it's going to be the Vote DB, Vote Result, Vote Worker, Vote Visualizer, Vote Vote, Vote Redis, and Vote. So there's going to be state, shutdown of CPU. We don't want a delay, and we don't want them to reboot. We want to see what Docker Swarm does. So on this visualizer, we'll start seeing that the containers are starting to go bye-bye, which is exactly what we wanted. And then to make things a little bit better, I wanted to expand the blast radius. And I wanted to know what actually happens if I also shut down my visualizer and I wait for everything to come back up in a few. So back to... Same thing, I'm gonna do a shutdown of this with no delay and no reboot. And as we saw earlier, this is just gonna shut down the visualizer, but we also just wanna see what actually happens when all these things happen at the same time. And we want to make sure that when everything comes back up, everything is healthy and we're still able to use our voter application and show the results in a very smooth way. We can go back to Datadog and also check in on when our containers are coming back up. We're seeing that some of them are slowly coming back, but not all of them. Our visualizer is still out. Okay. Let me go check. The nodes are still healthy. And then on our containers, we can see that things are coming back up. That is the visualizer, the vote database. The Datadog agents are also coming back. So now if we go back to the visualizer, we should have kind of like the same view that we had earlier. The visualizer, the database, the vote visualizer, the vote worker, as well as the results and the other vote containers that are needed, as well as Redis. So technically, everything should go back to how we kind of saw it before we started performing these chaos engineering experiments. So my app should be loading well, and so should my results. And then let's see if you're still able to vote. So we should actually be seeing like a change on it. Feel free to try going in and on port 5000 trying to do a vote. From doing practice runs on the chaos engineering experiments, actually shutting down the visualizer and shutting down all the namespace of vote actually kind of freezes Redis, where Redis continues telling you exactly the data that was there, but it's actually not being updated with anything that comes in. Okay, it actually is. Sweet. So in some cases, you perform a larger chaos engineering experiment and you start realizing that things are more broken than you expected. A few months ago, I did another talk using Redis, and when I actually did a shutdown of the primary container just to show that my Redis replicas automatically get promoted to primary, well, we actually realized that, yeah, my replica became primary as Redis promised me to. But then our primary wasn't configured with resilient practices. So the primary looked at replicas, and by that point, since we had already shut down the primary container, the replicas looked at primary and it's like, hey, you're empty, I'm gonna become empty too. So we actually suffered a full data loss, which is not something that you actually want to ever happen in dev, staging, production, or for any matter, especially as you're thinking about your users. So it's always good to kind of like think about how those things affect it. Okay, so I guess for this one, everything stayed working great, which is perfect. We had the hypothesis that things were gonna go well, but we didn't know until we actually tried it. Oops. So, as I mentioned, this is only the beginning of chaos engineering, trying to cover that monitoring and the disaster recovery space of what actually happens when you're trying to transition things to another space. But there's a lot more to chaos engineering than what I covered today. You can actually do more stuff of black holing traffic from your one container to the other, from your front end to your API to any other database, and that way you're actually able to test how things react. Some folks have actually been really burned with like the Amazon S3 buckets going down, so they have actually gone ahead and put a second provider for their images so things continue loading. So another way to be able to like think about chaos engineering is that you're able to think about outages that have happened at your company and then build a chaos engineering experiment around that. So for example, if you notice that your entire company website, the fonts, the resources, everything was broken when your image provider or hosting service goes down. Well, now you can be like, all right, we're gonna make sure to have an entire other provider for our buckets. So if we actually black hole all the traffic into our primary provider for this, we would actually be able to see that fallback mechanism and make sure that you're resilient. The same applies for like DNS, as well as anything else that you rely on other companies. Then there's other stuff you can do more on the state layer. So what actually happens when your company is preparing for daylight time savings or any other big change. With that change of skewing the time clock on your system, things behave in a very, very different way. And then you can think a little bit more of what actually happens if there's latency from one call to the other, or what actually happens if there's like some packet loss. So the cool thing about this is that it's not just for DevOps engineers, SRE engineers, or just infrastructure engineers. You can even bring in your front-end engineers to think about this, where you're like, hey, front-end engineers, you actually really care about the user experience. You wanna make sure that every user of your website has a really good experience. So you can make them think about it in a way of, hey, if you actually load this website, but you're loading it from a country that has less reliable internet, what do you actually see? How do my resources populate? Do the users even have somewhat of a good experience? And you can kind of replicate that by just injecting packet loss into your calls, as well as latency into other calls. So I wanted to leave y'all with a little bit more of other chaos engineering resources out there. There's a small chaos engineering book. There's an awesome GitHub repo that has been put together that has a whole bunch of talks and slides and other tutorials on chaos engineering. Gremlin has put together a community with resources on chaos engineering, DevOps, and site reliability engineering practices. There is a meetup that has like over 5,000 folks across the world that talk about chaos engineering, whether it's on Docker, Kubernetes, on the network layer, or more just focusing on monitoring. They cover all sorts of topics. And then there's also an entire Slack channel that has folks from all over the world in different stages of their engineer life, as well as how much they have done chaos engineering in the past. And if you want to stay in touch with me, the best way would probably be LinkedIn or Twitter. So feel free to reach out there. And I also put the short link for the chaos engineering Slack channel. I'm going to be around a little bit after the talk if you want to talk some more. And I'm also going to be hanging out at the Gremlin booth number 5. If you want to come talk more about the demo, chaos engineering, Gremlin itself. And there's also going to be a raffle of the Millennium Falcon, the ultimate one that's like worth almost like $800 today at like 4 p.m. and you have to be present. So feel free to swing by to also be part of that raffle. And I will now open it up for a few questions if anyone has some.
How about a round of applause? That was outstanding. Really great, Anna. Excellent. Okay, we do have 5 minutes for questions. Anybody like to ask Anna a question? Okay.
I saw that the containers were already loaded into your Gremlin free plan. How do we set that up? Is it on the pod or at level or a container level on the Docker side, or do you have APIs that you inject from the Gremlin side? Especially if you are in a hosted environments like Amazon or Azure, where the API levels are not as visible to others.
Yeah, so you actually just install it as a daemon. It doesn't run as root. It just kind of like sits there and then calls into our control plane to actually pull the experiments. So security and safety is like one of our core product values. And then if you're running on Kubernetes, you're able to deploy it on a Helm chart as well. And yeah, we've kind of like worked with all sorts of different environments. We are running on anything that's Linux and that has connection to the internet right now. And there's tutorials on how to get started on the gremlin.com/community that will have resources that will guide you step by step on how to do it, like on Ubuntu, on Amazon Linux too, as well as Kubernetes, Docker, as well as performing chaos engineering on Redis, Elasticsearch, and just like those first steps on getting stuff.
Are there any other questions? People are probably heading to lunch. That could be too. How about another round of applause for Anna? That was just outstanding. She will be available for questions up here at the stage. Please fill out the surveys on the app phone, And presentations, I think everybody knows by this point, are going to be available in SlideShare after the conference. Take care.